The coldest place in our solar system is the Hermit crater on the Moon, which is even colder than any surface on Pluto. Located near the lunar North Pole, this crater has been measured to have temperatures as low as -248 degrees Celsius, or -415 degrees Fahrenheit. These temperatures are even colder than what has been observed on the surface of Pluto. The extreme cold in the Hermit crater is due to several factors. Much of the crater is in permanent shadow, meaning it never receives direct sunlight. The sun's rays are critical for warming surfaces in the solar system, and areas that remain in darkness become extremely cold. On top of that, the Moon lacks an atmosphere like Earth's, which on our planet helps to trap heat and redistribute it around the globe. Without an atmosphere, the Moon's surface experiences more extreme temperature variations. And finally, the crater's location near the lunar poles contributes to its permanent shadow. The Moon's tilt, much like Earth's, causes the poles to receive less direct sunlight. The Hermit crater, formed roughly 4 billion years ago, is characterized by its heavily worn and eroded structure, with a rugged and notched outer rim shaped by numerous past impacts. Studies have suggested the presence of significant water ice within Hermit's permanently shadowed regions, where sunlight never reaches. They also suggest that 2/3 of the crater's permanently shadowed regions might contain varying amounts of ice.
A massive deposit of water ice has been discovered beneath Mars' equator. If melted, it could cover the planet in an ocean about 1.5 to 2.7 meters deep. This finding, resulting from 20 years of the spacecraft's exploration, marks the largest known quantity of water ice at the equator, which was previously detected in smaller amounts. The ice, buried up to 3.7 kilometers deep and obscured by a thick layer of ash and dust, presents significant challenges for extraction, but holds immense potential for future manned missions to Mars. This discovery sheds light on the Medusae Fossae Formation, or MFF, a massive, wind-sculpted dust source on Mars. Researchers had long pondered whether the MFF's lower density was due to being a giant dust pile. However, new radar data from Mars Express reveals that these deposits are actually water ice. This discovery hints at the planet's changing obliquity over time. The research suggests that during periods of high axial tilt, ice may have formed at the equator and subsequently got buried, offering a possible explanation for various Martian geological features observed today. Water is essential for life as we know it, so its presence on Mars fuels the ongoing search for extraterrestrial life. Moreover, water can be split into hydrogen and oxygen, which can be used for rocket fuel and breathable air, respectively. This makes Mars missions more sustainable, as astronauts can potentially generate vital resources on-site, reducing the need to carry them from Earth. As we approach a black hole, we encounter an invisible boundary called the event horizon. Beyond this point, the gravitational pull is incredibly strong, so much so that not even light can escape. The size of the event horizon depends on the mass of the black hole. The closer we get to the black hole, the harder it becomes for objects to escape its gravitational grip. Deep within the black hole lies the Singularity, the epicenter of complexity. The exact nature of what lies within a black hole's core remains a subject of theoretical speculation, as the extreme conditions within make it impossible to directly observe or describe with our current scientific knowledge. Visualizing the Singularity presents a challenge, as our current understanding of physics is limited in this extreme environment. Scientists believe that the Singularity is a point of infinite gravity and density where matter is thought to be compressed into an unimaginably tiny dot. To understand the Singularity, scientists seek a unified theory called quantum gravity that merges the principles of general relativity and quantum mechanics. This theory could offer a deeper understanding of what lies at the core of a black hole. However, this theory has not been fully realized, leaving the nature of the Singularity largely unknown. By combining information about stars, black holes, gravitational wave detections, and cosmic evolution, scientists have arrived at a robust estimate of approximately 40 quintillion black holes in our universe, a number exceeding previous expectations.